Okay, let's get started. So far we completed discussion about Git architecture, and you know how to install Git. And we have created our own repository in GitHub. So you all know creating a new repository, and you also know how to modify the file or create new files, and then commit and then push those files to the remote repository. You also know how to generate the token password. That's what we have discussed. So let me go to our repository. So this is our repository which we created in the last class, faculty 61. Okay. Let me remove it. Let me clone it again. Faculty 61. Git clone faculty 61. So that's our repository. Then in our repository, we have two files. Correct. So this is our local repository .git. This is our source area, right? So how do you modify the file? For example, you open the file which is in the source area like this. You can add something here, and then git status. It says you have the changes in source area, red color. So we add it to the stage, correct? Git add file name, git status. It is in staging area because it's shown in the green color, and we have to commit it, correct? You all know how to commit the file changes. Git commit -m commit message, say fixed bug, right? Say 2340, for example. Okay. And then you say git push. So changes are pushed to the remote repository. So if you see at the time of committing the file, it is not asking me my username and email ID because my credentials are already stored here. Okay. My username and email ID is already configured in this mission. That's the reason it is not showing. But if you try to, if you had tried to commit the changes, you would have received an error, right? Saying, please let me know who you are. So let me remove, my configurations. On mute. So as I said, my username and email ID is already configured in this particular file. Okay, I'm removing it so that I can show you that error. So go to the repository, right? And then let me try to commit something. Login.java. Say something like this. Static void main, something like that. Git status, git add login.java, git commit -m, added some class definition, something like that. And then the file name is optional. If you don't give the file name, it will take the file whatever you have in the staging area. See this? This is the error you would have got, which is, please tell me who you are. Because it stores the history, right? It stores your username, email ID, timestamp, and then commit message, right? Git stores the file along with the changes files. It also stores some metadata, correct? So it doesn't know now. First time when you commit, since it doesn't know your name, it is throwing me this error. Okay. So how do you configure it? There are some commands here, correct? Just copy paste them. So I'm going to configure my username now. This is how you have to configure. Okay, before you commit, you have to configure your username. Git config. Remember this. Hello Git, please configure my user email, user.email. Okay. And then in double quotes, you can give your user email. This is my email ID. Clear? Git config, please configure. What is that you're configuring? User.email and then email ID in double quotes. Sometimes you may be working or you may have to work with multiple repositories. Okay. So if you use ---- global, you know what it does? This will use the same email ID for all the repositories in the same mission, right? So you may have to work with multiple repositories. Okay. You clone repository 1 in one place and then repository 2 in another place, and then like you are working in 2 projects, for example. In that case, global will be helpful to you. So this will configure the same email ID for all repositories. Done. Again, hello Git, please configure user.name and then name in double quotes, something like this. And again, I'm using global for all the repositories. Global, right? Done. If you want to see all the configurations of Git in your mission, you can use this command, git config -list. This is very much helpful for you. See this? This is the username and then email ID. There are some other, default configurations. So don't worry about them. So that's how you list what username and then email ID has been configured in the mission. One more thing. Do you need to configure the username and then email ID every day? No. So once you execute these 2 commands, Git stores your name and then email ID in this particular file. Okay, remember, you don't need to execute these commands every day. So Git stores the credentials, username and email ID here, ls-a in your user home directory. Okay, user home. So it creates a file called .git-config. See this? So here it will store your name and then email ID. And it refers this particular file and then uses username and email ID. So that you don't need to configure every day. Interview questions. How do you configure the username in Git? Git config different global username. How do you configure email ID? How do you list all the configurations? Git config -list. Can you tell me where Git stores the username and email IDs? What is that file name? User home .git config. So that's how you configure your username. Now let's try to commit our changes. Okay, Git status. We have one file in the staging area, right? Let's commit this. Git commit -m file name. Now, since it knows the username and email ID, it'll configure it. It'll commit. See, if you want to see the log of history of that particular file, git log login.java. So this is the username which I configured recently. Earlier, it was Harry user was configured. This is the new one. So first day, when you join as a DevOps engineer in some company, probably this is what you have to do before you change anything. So you have to configure your username and then email ID. So if anything, if something is not working, if there are any issues in this particular change, people people can connect to you using your email ID. Don't give your personal email ID here. This should be your official email ID. Clear with configuring username and email ID? Any questions you have so far? Easy, right? Any questions? Okay. And you know how to add some changes to the staging and then why we add the files to the stage, correct? So basically, staging enables us to group the changes, right? So this is our Git architecture. So Git remote repository. So if you want to work with this particular repository, you have to first clone the repository, correct? So when you clone this particular repository, you get .git source and then stage, correct? So this is your Viculty repository, your project name. So when you clone, it'll create a directory, and then you see .git here, source area, imaginary folders, and then this is your stage. Correct. So first you have login.java. When we clone, we get login.java in source area, modify, add it to the stage, commit it to the local repository, and then push it to report. That's how we work. Correct. Is it mandatory to, stage the files? No, it's not required. So as I said, if you have multiple files here, right? If you have changes in multiple files, assume that you have, 5 files related to a feature or related to a bug fix. So since there is a staging area, we can move only this particular 5 files and then commit. So you have, all 5 files in a single commit. So that gives you, better history. Tomorrow, if you want to know, right, what files, were changed to fix that particular bug. If you see this particular history, this particular commit, you will get everything, right? So that's how staging helps you. But staging is not mandatory also. You can directly commit the changes. If you want to skip the staging, how do you skip this? What is that command we use? You don't want to group the changes in staging area. You want to directly commit. You can do it. Okay, how do you do it? See this? Git status. So I'm modifying some file. Okay. Say something like this. Don't worry about what changes I'm making here. Something like that. Status. Okay. Now I don't want to add it to the state. I want to directly commit it. You can do that. So how do you commit? Git commit. Okay. -m. And then your commit message. Added something, some comment. Okay. Format modified. Since you are skipping the staging, you have to use an option, -a. If you use -a, remember this. Okay. Commit and then add and commit. A means add. See, for you, it is, it's like, it tells you that, you can skip the staging, but you have to tell Git, right, that I want to, I'm skipping the staging or I want to skip the staging. So you have to use this option A. Remember that? See, it says paths pom.sml file with -a does not make sense. Remember one more thing here. If you are skipping the staging, you have to commit everything. Assume that you have 10 files in source area. If you're skipping the staging, you have to commit all 10 files. Otherwise, it will not allow to, selectively commit the files. Now, that's the reason it is throwing this error. See this? I'm skipping the staging, git commit -am, and then I'm giving the file, right? What is the rule here? You cannot selectively commit the files if you are skipping the staging. So I'm giving the file name, I'm mentioning the file name is what? I'm selectively, committing. So that's the reason it is throwing that error. So when you are skipping the staging, you have to commit all the changes that you have in source area. If you have 10 file modifications, you have to commit all. That is the reason it is not allowing you to mention any files. Okay. So remember, first rule, okay? If you are skipping the staging, you have to commit everything. So that is the reason, don't give any file names here. That's the first rule. Second rule, if you are adding any new files, okay, if you have any new files, you cannot skip the staging. If you are committing something first time, you cannot skip the staging. Okay, second rule. First thing, what is the first rule? You have to commit everything. If you are skipping the staging, you cannot be selective. Second rule, if it's a new file, you have to go through the staging process. You cannot skip the staging for new files. Let me show that to you. Let me create some file, okay? Say touch ansible.txt, some file. git status, right? Say I'm skipping the staging, say for example, git commit hyphen added ansible conf readme, something like that. See what it says? It says there is a new file, right? Nothing added to commit, but untagged files present. That untagged file means new file. So it says you have to go through the staging process. I've mentioned these two notes in the notes. Okay. So if you want to skip the staging, you need to commit all pending changes. For new file, you have to go through the staging process. Okay. Remember those two things. See, adding files to the staging area is like a best practice. Okay. If you want to selectively group the files related to some work, use staging. Otherwise, you can skip the staging also. Okay. It depends on your requirement. A lot of times people skip the staging or they don't know how to use or like when to use a staging. So they just say, clone, modify the code, add, commit. That's totally fine. But now you know, right? So when we use staging and when we can skip the staging. So anything is fine. But if you are working on something, try to commit everything in a single commit. That will enable better history. In that case, staging is helpful for you. Try to use staging area in that case. If you don't have that requirement, assume that you are committing only one file, skip it. That's totally fine. Clear with this? Any questions you have about staging?
So one question, can we only stage one file at a time, or can we group, let's say I have like 10 new files. Can I commit all of them in one go?
Yeah, you can do that. So you have say 10 files here. You can stage one by one. Git add file 1, git add file 2, git add file 3. One by one, you can do the staging.
Okay.
And then when you commit, whatever you have in the staging, everything will go.
So
Plus,
if the command line, I have to add git commit -m recent and then all the files.
you don't need to add all the files because by default, when you are committing, it will take all the changes from the staging area and then commit. So you don't need to. You can add, but without mentioning the files also, it will commit everything, whatever you have in the staging.
Okay.
Yeah. Okay. So that's about the stages. LS, git logs, a form that is simple.
Sir, one more question, sir. Sorry to interrupt.
Yes, yes.
Uh, so, so can we add only files, or can we add directories also to the Git?
Directory is
We
also same. Same command for directories also.
okay. So we can add directories also using same command.
Yes. But you
Okay.
cannot add empty directories. Remember that. Okay, let me create some directory.
Okay.
mkdir. Assume that I want to create a directory. Okay. mkdir, say DevOps. That's a directory name. Okay. Git status. I want to commit this into the repository, this directory. Git add. Let me first commit this one. Okay. So as I said, you cannot skip the staging if it's a new file, right? So you have to, since it's a new file, you have to add it to the stage and then commit it. Git commit -m ansible config file, something like that. Okay, done. ls-a. So assume that I want to add a directory. I have created a directory. Now, see this. There is a new directory, right? But it is not telling you that there is a new directory in the source area because it's an empty directory. You cannot commit empty directory in Git. Remember that. If you want to commit that, there should be a file inside it. So let me create a file. Touch ydevops.txt, something like that. Okay. Now you can go git status. So now it is recognizing this as a new one. So you cannot commit empty directories. It is not even telling you that there is a new directory if it is empty. Now you can commit it, same thing. Git add directory, whatever you have in the directory, everything will be staged, and then commit it. Git commit -m, say DevOps source code, something like that. And then you can give the directory name, or that's optional, because by default it will commit everything that you're in the state. Git status, git push, so this is my GitHub token. Okay, now we just remove it and then try to clone again. You'll be having directory there. Git clone y36 see, there's a directory. Clear? It's the same thing, same process for file or the directory, both are same. Okay. So let's see the log of permanent file. Git log file name, right? So this is the first commit, this is the second commit, and this is the third commit. So in this particular file is modified 3 times. So maybe you have created the file here because it's the first one. You modified something here and then something here. And if you see, commit has a commit ID. As I mentioned before, it's not a simple number like 1, 2, 3, 4. This is called as a SHA value, SHA, SHA, or simply commit ID. We call it as a commit ID or SHA value. Mostly we call it as commit ID. And then you know this, right? Username and then timestamp and then commit reason, commit message. What is this number? So this number is called as a SHA value, right? So just for your information, nothing great about it. We don't need to worry about that. So you modify the file and then you add it to the stage and we commit, right? Just before you commit this particular file, right, to the local repository, you know what Git does? It'll run a command on that particular file, sha1 sum. That's a command name, okay? So you have the file, right? So on this particular file, which you have in the stage, it will run this command, sha1 sum. This will generate the code, that commit ID, something like 1, 2, 3, ABC. And then whatever number is generated by this sha1 sum command, that will become commit ID. It will use that as a commit ID. And then this is a new commit for it. Each and every change, each and every time you modify something, it will create a new commit, right? New version, right? So that's how this particular SHA value is generated. It's a hexadecimal number. Hexadecimal means 0 to 9, combination of 0 to 9 and A to F. You want to know about that SHA1 sum algorithm command? See this. SHA, forget about Git for some time. SHA1 sum devops.txt. See this. This particular code is generated based on the content of this particular file. Now I'm running it again. Content is same, right? So the code is also same, 709, 709. Let me modify that particular file, devops.txt. I'm adding something. Now there is a change in the file, right? See, it is giving you a new code. So that clears that this number is generated based on the content of the file. So why Git must be using this particular number? So these are the commit IDs, right? Commit IDs should be always unique. Commit IDs should be always unique. And then see 1, 2, 3, 4 also you can use. That's also a unique only. In that way, it can generate the unique numbers. But they say that using this particular SHA value, right? They make sure that there is no violation in content integrity. I'll explain that. So what is happening here? You have some changes in the staging area, correct? When you run git commit command, what is it doing? It is taking the file. On that file, it is running this particular sh1 command like this. I'm manually running that command on that file. Assume that devops.txt is in the staging area. Okay. Devops.txt is in staging area. So when you commit, what it will do internally, it will run a command like this. Okay. And it will generate that number. That command will give this number, and then it will use that as a commit ID. So that's how the commit ID is generated. We call this SHA1 sum as content integrity algorithm. What's that? Content integrity algorithm, meaning as long as content is same, it will give you the same code. If there is any change in the content, number is different. So Git is using that technique to make sure that commit IDs are always unique. So for example, why they would have decided to use this checksum number or SHA sum number SHA value instead of using 1 2 3 4 5. So for example, you have a file in your repository, right? This has some number, correct? So 1 2 3 ABC, that's the latest commit. 1 2 3 ABC, that's a commit ID. Say first copy. Somebody is cloning the repository. Somebody is cloning the repository. Okay. You have the file here, login.java. But what is the guarantee that this particular file and then this particular file both have the same content? What is the guarantee? You would have faced this issue, right? So you're downloading some file in your laptop. There is a file here. You're downloading the file. You see the file in your laptop, but it is corrupted one. Possible, right? Because of the internet issue or whatever. So you have the file somewhere in some website. You're downloading it. So sometimes a movie, for example, you see the movie file, but if you open, you cannot open it because it's a corrupted one. That means the same file is not downloaded properly. There is some data loss. Possible, right? When you download. So Git has this commit ID, right? 1 2 3 ABC. So how it makes sure that file, the repository or file is downloaded or cloned properly, it will compare this value. So this has some commit ID, right? 1 2 3 ABC. So once the clone is done, you run git clone command, right? So after clone is done, for example, it will check what is the SHA value it has. What is the, it will run, say, for example, that, SHA1 some algorithm. It will find out the code 1 2 3 ABC. If this code both are same, means what? Both files have the same content. Content integrity algorithm, whether the content is same or not. So because of different reasons, right? It uses this the SHA value internally. We don't need to worry about that. As a user, you don't even need to know how that code is generated. Since you are learning, right? I know something. I'm just sharing the information with you. Otherwise, you don't need to bother about that number. Just remember, we call that as a commit ID. It's a SHA value, and how it generates that SHA value. Say, for example, I'll give you another use case. You have a file in remote repository, cloned it. Okay. Assume that you modified the file. You are running git status command, right? So far, git status. Now, can somebody tell me how Git, when run git status command, how Git knows that, okay, this file is changed? You have a lot of files here. How it knows that this file is changed? Yes. Using that SHA value, correct? Say, assume that this is the latest one, right? Commit ID is 1 2 3 ABC, right? The moment you run git status command, it will calculate, it will generate a number using the SH1 sum algorithm. Assume that this is 1, 2, 3, BCD. So this number is generated based on the content, right? 1, 2, 3, BCD, and what you are having at the time of clone, fresh file 1, 2, 3, ABC. Since the SHA value is different, it declares that okay, login.java is modified in the source area. So it uses this number, for different reasons. That's the internal, functionality. Okay, we don't have to worry about that. Just remember that number is generated based on the content of the file, not just based on the content of the file. It takes a lot of other things into account. For example, you are committing, right? So it'll run that command, correct? SHA1 sum command, not just on the content. It will take your username, because what if other users also modify the same thing? Possible, right? See, Harry, Sally. Okay. Harry added some line. Okay. And then Sally also added the same line. Harry added the, Harry modified login.java. Sally also modified login.java. And then both are committing. In that case, if it is taking only the content of the file, what will happen? The SHA value will be same, right? Commit ID will be same. And two commits cannot have the same number, right? So that's what it does. It will take the content. It will also take the username, timestamp of the commit, and machine details, a lot of things. So they won't tell us, how that number is generated. Usually SHA1 sum generates based on the content, but Git goes beyond that. It's not just the content. It'll also take the username and a lot of things. They say that you don't worry as an user. We make sure that no matter two users are modifying the file with the same content or whatever it is, we take care of generating. We make sure that you have, the unique commit ID. So that's their job. That's a development of Git. That's the internal functionality of Git. So this is just for your information. That's all. We don't need to worry about that number. Any questions about this commit ID? Any questions? So just before you commit, okay, the file, it will generate this number, and then it will use that as a commit ID. And you know why it is not using 1, 2, 3, 4 simple numbers? Because it has to check the content integrity, right? As I said, when you run git status command, it has to list the modified file, right, in red color. So it uses, this number for, in those kind of scenarios. Any questions about this command, about that commit ID?
It's a small question actually. So it's not about commit ID, but just one question. So two people at a time cannot modify the same file, right?
You can modify the same file at the same time. Any number of people can modify a file at the same time.
Okay.
Why that question, Rajshekhar? Why you think, I'm just trying to understand why you think two people should not modify or cannot modify?
So when okay, two people modified the same file, so they have committed and they push the code. How single file has that effect when two people modify and push it to the Git? So
Whoever commits first, whoever pushes first, their code will be committed in the remote repository. Say you have login.java, say for example, right?
Yes,
Only
sir.
one commit you have. Sally, Harry, both are working on the same project. So this guy also get the first commit. Okay. Both can modify, right, at the same time. So Harry is modifying the file. Harry is working on fixing a bug, whereas Sally is working on developing a new feature, for example. Okay. Harry adds it, and Harry commits. It will get a new commit ID, right? It will get a new commit, right? New version.
Yes, sir. Yes.
This is Harry's code, correct? Now Sally adds the file. Sally commits in her laptop. This is Sally's laptop. This is Sally's change. This is Harry's change. Now assume that assume that Harry completes the work. Harry will push first. So Harry's change will come in. This is 1, this is 2. Now Sally has 1, 2, some number, okay? 2, 3, A, B, C. Okay. Now I explained this problem in the introduction class, overriding problem. Now if Sally commits, it will not take Sally's change. It will not take. Why? Can somebody tell me?
Because Sally need to do the code pull, right?
Yes. So assume that Git takes this change. See, Sally took the first one and then modified something. That means this and this particular Sally's change has first one and then this one. But the latest one, this one, doesn't have Harry's changes, correct? If anybody takes the code now, it will give the latest, right? Latest doesn't have this. So since there is a new change, Harry change, when Sally tries to push, Git will throw an error to Sally saying, I have some extra change, you pull it first. So what Sally will do? Sally will run a command called git pull. When Sally runs git pull command, what will happen? This is merged. Now this has latest. Now it will accept. So 3 has, right? Sally's change has first one and this one and this one. So remember one thing. Any number of people can work on the same file. But if assume that you are pushing a file, assume that there is some new, commit, new change in the remote repository. Before you push, you have to you have to pull the changes and then you can commit. And you don't need to check, that there is a new version in the remote repository and things like that. You just push it. If there is any new, it will throw you an error, and then just git pull command, and then you can push it. So that way, many people can work on the same file. So this is Harris one, this is Harris one. In fact, that's the advantage of using the source code management tool. Since we are storing the code in the source code management tool, we get this, feature, and Git is helping us without overriding each other's code. Rashid?
It is clear, sir. It is clear. Thanks.
Hello?
Go ahead, Satish.
Okay, sir. In this case, let's say that we both are modifying a file. Okay. You picked a copy of the file. I also picked a copy of the file. Okay. I committed first, and now the main branch, it has an updater. Okay.
There is a lot of background noise around you, Satish. I cannot hear you clearly.
Hello?
Probably you can come close to the mic.
Hello.
Yeah, I can hear you, Satish. Go ahead.
Okay. So let's say that we both are picking one file and making the changes.
1 second. Since I cannot hear you properly, let me break your question. So Harry, Sally, right? Both are working on the same file. Okay.
Yeah.
So there is one change in the remote repository. So this is the latest one. Say, for example, 1. So okay, fine. Both have cloned the code. Fine. Then
So one person has to run the command and then that comes to the main. Okay.
that was not clear, Satish. Come again.
Is it clear now?
Yes, better.
So if one person pushed a file, some update, let's say, another person when he tried to push it, it would be giving that it is not the updated file, correct? Now
Yeah.
he has to pull that file and then merge it with the file what he has done and then again push it. That's what you said, right?
Correct.
Okay, so because in that case it would be a conflict terms, right? Because when he pulled the file, it would be merging with the existing copy of the file what he has. So maybe he would have done the changes in that file based on the previous logic, right? Now if it is just updating with the file what you have, then the whatever the update you did, it is not as per the old logic. It is based on the new logic, which means that whatever the coding you have done is incorrect, right?
You're talking about the conflict, right, Satish?
Sorry.
You're talking about conflict.
I'm
See,
talking
that,
about the file. I know what I am trying to push.
okay, that's so you're talking about say, Sally runs git pull command here in this case. So when she runs git pull command, she may see a conflict here. Is that what you want to find out, correct?
Yeah.
So there is a separate topic on that, Satish. What is conflict? I'll take that question here. If I explain properly, other people don't understand. Can I answer that question here after this merging topic?
That's why I wanted to check with you. You understood, right? Because that's the reason I wanted to check.
Mm-hmm.
Okay, thank you.
I'll note it. Okay, git pull conflict. So you mean this is the if this is not your question, let me know. Okay. So this guy commits something, pushes something to the remote repository. Sally also has a change here. Okay. Assume that this person modified line number 5. This person also modified line number 5. Here it is a is equal to 10. Here it is so same line a is equal to 27, for example. When Sally pulls, Harris changes. So now line number 5 will be can be there is a conflict here. So same line cannot have two values, right? Line number 5 is a equal to 20 here. Here line number 5 is a equal to 10. So which one it has to take? If it takes Harris changes, for example, 10, Sally will lose 20. So there is a conflict here. There you cannot decide whether it's a 10 or 20. So yes, you will get the conflict. Is that what you're talking about, Satish, or your question is different?
Hello, are you able to hear?
Yes.
Okay. Okay. I was not able to hear, sir. So I had some, microphone issue.
Say for example, login.java. Okay.
Okay.
Now line number Harry, line number 5. In line number 5, this guy modifies, the previous thing from something to a equal to 10. Line number 5, a equal to 10. Who modified this? Harry. Line number 5. At the same time, Sally, right? In Sally's login.java, line number 5 has a equal to 20. She wants 20, Harry wants 10. Now, before Sally pushes the changes, Sally has to take Harry's changes, right? She has to pull, right? So Sally is pulling the code. Now, line number 5, Harry wants a equal to 10 at line number 5, correct? But Sally has 20. Can it take a equal to 10 here? If it takes 10, pulling means what? You are taking Harry's changes, right? You are merging. If it takes 10, for example, now Harry will say, I want 20. Why you are making, it 10? So Git cannot decide whether it has to be, whether that line number 5 has to be 10 or 20. So we call this situation as a conflict situation. So it happens. When you say conflict, is this the case you are talking, or you have?
Exactly. Yeah. So basically that is the one. But in case of coding, there could be multiple. For example, if it is a HTML file, there could be some JavaScript as well merged, right? So it's a combination of the person who is doing HTML, he will be doing HTML, the JavaScript person who will be doing JavaScript. So in that way, there could be conflict, like you said, right? Simple example you give. So if we just merge whatever the file there in the main with the file what you have locally copied without checking what is the difference, then that creates a conflict, like you said, right? That's what I mentioned.
So this is the conflict, it handles. But if somebody is in a login.java, somebody writes HTML, and then somebody writes, JavaScript, for example, it doesn't know. Git doesn't know whether it's HTML, Java, or whether there is error or
It will just merge whatever there in the main.
Yes, whatever you have, it will just merge it. It will just combine. That's all. For Git, it's just a data. Okay, some content. So it doesn't understand all this. Okay. But see, that's a rare case, right? See, this guy, when it's a login.java, why they add HTML? Why they add JavaScript here? But in some cases, possible, if you take out Java or JavaScript and things like that, but Git doesn't understand all that stuff. It will just merge the content, that's all.
Okay, got it.
Yeah.
Sir, I had a question. The developers would be extensively working on the Git, correct?
Yeah.
And like we as DevOps engineers, we would be just pulling that code and using it whenever we have any deployments. So we would not be extensively working as the devs, right? So we would not face these many scenarios in real time.
That's true. So we won't face these many scenarios in real time, true. But if any other users, say developer, for example, are facing the issues, they come to us. So we should be in a position to help them out because we are considered as experts in Git in real time.
Understood.
That's
Thank
and
you.
we are learning very extensively. Because we only manage Git and repositories and everything. We are primary contact for Git. Okay.
Thank you.
So that's about the stays. And the commit structure, right? There is something called SHA value or commit ID, username and email ID, and then timestamp and commit message. Okay, fine. I just want to introduce one more command to you. Git status. We don't have any changes. Okay. So git log form.xml file. Using this particular history, you can come to know that form.xml file has been changed 3 times. That means, first one anyway, people, this is the commit for creating that particular file. Okay. Again, somebody modified this file, somebody modified this. So for example, or I just run git log command. I just run git log command. Okay, fine, leave it. 1 second. Take the previous one only, form.xml file. So you want to know what content is modified here in this particular commit. Can you see the content modification in this particular commit? No, right? So for example, developer uses git log and then form.xml file, and then developer know that okay, this guy changed something. Developer will come to your desk, says, okay, I see that somebody changed the file. Okay, this guy, but I want to know what content. I want to know the content modification. What content has been changed? How do you know? That's where you use another command called git show. Git show, and then you can give the commit ID. Assume that you want to know the content modifications of this commit. Git show and then commit ID. First 7 is also fine. Okay, or you can copy the whole. You can copy that complete SHA value, or first 7 characters is also fine. 7 plus minimum 7, because they say that first 7 is mostly always unique. So git show and then commit ID. See this? Git log is just giving you this information, whereas git show is giving the git log output. This is git log output, plus it is also giving you the content modification. You see here, plus and green color means somebody add this line. Remember here, you see plus green color means somebody added the line. If somebody deleted something in this particular form.xml file, it will show that with minus and red color. Minus red color means somebody removed the line. Plus green color means somebody added something. So that's how you know what has been modified in a particular commit. You want to see here git log form.xml file. You want to know what modification is done here. Git show. See, git show, then I want to know what has been modified here. In this particular commit, login.java file is modified. In login.java, somebody deleted these lines. See, in one commit, you can modify multiple files, right? So in this particular commit, you modified login.java and then pom.xml file. That means login.java, pom.xml file. Okay. You modified and then staged. Pom.xml file is modified and then staged. And then you committed 2 files together. So in this particular commit, you have two file modifications. One is login.java, right? Somebody deleted this particular lines in pom.xml file. Somebody deleted these lines and then added these lines. Now you see this git show. Let's say the first one. Since it is the first, you would have added it newly here, right? So here it says new file. So you created the file with this content initially. It's a new file. That's how you can see the content modification of a particular commit. Clear about git show command? Any questions about this? See, developers use this show command multiple times. For example, they go and then run git log pom.xml file, say for example. There is a commit here. Fixed bug 123, fine. Bug fixed, say this 123 bug ID is fixed 1 month back. Again, for some reason, you see the same bug, crops up. Now developer wants to know, right? Okay, this bug was fixed 1 month back, but now again I see the bug. Why? Okay, what content, right, has been modified 1 month back? They want to know. In that case, what is that command they use? Git show and then commit ID. It will tell you what files are modified, right? As part of that particular commit, you can see the file name as well as you can see the content changes also. In those kind of scenarios, Git show is very much helpful. Remember, Git show, so for example, git log pom.xml file. I'm listing the history of only one file, that is pom.xml file. What if I want to see the history of the complete repository? Git log. So git log will give you the complete repository history. If you have 100 files, all 100 files history you see here. So developer just runs git log command because he doesn't know the file name also. If you know the file name, you can run git log file name. If you don't know the file name, you just say git log, right? Git log, and then developer is scrolling down, says okay, fixed bug 234, fine. This is it was fixed, but now I see the same bug cropping up. So I want to know what has been modified here. See, developer doesn't know the file name or content changes and things like that. So how do you know that? Git show, okay, commit ID. So in this particular commit, okay, anyway, Harry and then date and this thing. So login.java file is modified and somebody added these two lines. So that's how you can see more information about a commit. Show will give you more information, whereas a log will just give you this. Show command will give you more information about a particular commit. So git show, now we'll be using git show command very frequently in real time. Clear about git show command? What's the syntax? Git show and then commit ID.
So one doubt.
Mm-hmm.
Git show and then you put the UID, right? So you're not copying the complete UID, just copying off. So this is just sufficient that it would understand which one you are referring to.
Yeah, it understands. You can copy everything, or they say that if you read the Git manual, they say that first 7 is also fine. It understands because first 7 will be always unique, is what they say. If, for example, see this first 7 characters and then first 7 characters may be same. If it is same, then copy one more or copy everything. They say that first 7 is almost unique. So minimum 7 you can copy.
So one more thing. So for example, if you are downloading a software from a website, it would be showing the SHA value, right? So you download, then you have to command run and see that the file what downloaded is not corrupted or missing any data, right? So is it that value coming from here, or they do it separately after having a patch or something, let's say?
No, they do it separately. That is
Okay.
different. That is not the Git SHA value. They do it separately. They generate it separately, like how we ran that SHA value command.
Okay.
See this, everybody? Forget about Git. See this SHA value, SH1 sum command I have shown you, right? Say SHA1 sum devops.txt. So we call this as content integrity algorithm, or we call this as checksum code. Git is using this particular number for different reasons. Okay, you can also use it in a general. This command has one more lot of advantages. For example, so this is your website. Okay, website, and you have some installer here, some zip file, a.zip. You have a.zip file. Assume that this is your software. Okay, your user, you have a lot of users. This is your user. User wants to download this particular your software. So the user downloads this a.zip. As I said before, if there is any issue in internet and and things like that, you see a.zip file here. You see a.zip file, but that may be corrupted. Correct? You may not be having exact content of this particular version file. So your user extracts a.zip, and then there are some files missing there, for example, because it's a corrupted one, right? Now your software is not working because there are no few files are missing there. This guy will come to you saying, I downloaded your software, but things are not working. It's not actual issue, right? It's not the it's not an issue of your software. It's a download issue. So how do you how can your users make sure that they downloaded exact file? How? What this guy will do? This guy your software provider, for example. So when you create this zip file, generate a SHA value. Run this command sha1 sum a.zip. Okay, it will give you 1 2 3 abc, and then you place this 1 2 3 abc blah 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 sha1 sum. So your users download the file. That means you have kept the SHA value of this particular software zip file. You have to do it. You generate it like this manually, and then you keep it in your website somewhere. So your user downloads the file, and then they also run this same command sha1 sum a.zip in their laptop. Correct? They will get some number right here, 1 2 3 abc. If this number and this number is same, that means what? Your download is perfect. Correct? Both have the same content. Assume that this guy gets new number, some other number, 1 2 3 b c d. This number is generated based on the content of this particular file, right? So this number is different. This number is different means what? Oh, this file is content is not exactly same as this. So see, now you see how people are using SH1 sum algorithm to check the content integrity, correct? To check whether the content is same or not. So you would have seen these kind of things in some websites. Let me try to show you. I think that is there in Maven. Maven download. In some websites, they give you that SHA value. Some people don't worry about that. See here, .gz file, right? They are also giving you SHA512. Click on this. See, this is the SHA value. So you download this. I have downloaded, okay? .gz downloaded. This is the file which I downloaded, right? So I run this command, SHA512. It's not only SHA1 sum. There are a lot of such commands. One more thing, clear. Clear with that? It's not only SHA1 sum. See, these guys are using SHA512, SHA1 sum. There is something called, I think, SHA SHA-SUM, SHA-256 sum, SHA-512, lot of commands. All these commands do the same job. Okay. So see what you can do, how you can make sure that .gz file is downloaded properly. Download it. So I'll run this command SHA-512 on this. I'll get some code, right? I'll compare my code with the code given in the website. If this code and then my code is same, that means file is downloaded properly. People also use these commands, for checking the content. So if you're downloading something and if you see something like this, that means they are using that number. You can verify whether the download is proper or not. Clear with that?
Yes, sir.
And Satish, yes, you have to generate that and then keep it in our website. You have to generate it manually. See here, SHA-512. So you can download this and then you can verify that.
So, so in website, when they upload a new version of a software, okay, for example, Google web browser or any of this one. So who does the SHA value?
Whoever uploads this particular file.
Okay. So who get it? Do they get it from the developers or from the DevOps team?
Say this, there is a .gz file right here.
Yeah.
This is Tomcat installation.
Okay.
So who creates this installation? Maybe Tomcat companies, that Apache company, some DevOps engineer creates this particular .gz file.
Okay.
So whoever is creating this particular .gz file, that person generates that code, and then probably that person gives that code to this website developer. So
Okay.
website developer just adds that code here. Okay, I used to do this. So in my first company, right, I used to create some .gz file for some software. Okay, so I create .gz file and then I run that SHA-1 sum on that particular file. I get some code, right, and I call my website developer saying, okay, he uploads. Developers, whoever is taking care of this website, they upload the file, right? So I tell them, upload the file and then make sure that you create a link. I want you to create a link like this, and then when somebody clicks on that link, show me this code so that my users can verify it. So developers do that. This whoever is maintaining that website, and whoever is creating that particular file, that guy gives the code.
Okay, got it.
Yeah. So that's a generic usage of SHA-1 sum algorithm. You can call it the algorithm or command or whatever. So people use for those reasons. Quickly, this is your mission 1, mission 2. Okay, you have a file, say for example 1 GB file, right? You're copying the file from this mission to this mission. It's a 1 GB huge file, right? So once the file is copied, you want to make sure that file is copied properly. What do? SHA-1 sum file name. It will give you a code 1, 2, 3, 4 ABs. Correct. Once the file is copied here in this mission, go and then run the same command SHA-1 sum and then the file name. It will give you 1, 2, 3 ABC. If this code and this code is same, means what? File is copied properly. If you get a different code here, that means different content. So file is not copied properly. So you can also check. You can also use this SHA-1 sum to check if the file is copied to the other end properly or not. Wherever you want to check the content, use that. Okay. So that's the general uses of SHA-1 sum kind of commands. So when it comes to Git, as I said, you modified the file, you added to the stage. Just before you commit, it will run that command on that particular file, and then it will use that numbering. So before we proceed further, I want to make sure that you all understand the concept that we did so far. You all know what is the remote repository, correct? You have two kinds of repositories, public, private. So remote repository is the place where all users connect to. People don't take the code, from the Harry, will not call Sally saying, Sally, I heard that you have some changes in your laptop. Can you give me the changes? No. People take the code from the remote repository. Correct? You know what is working directory? This is called a working directory. Once you clone the code, you get this directory, right? You call this as a working directory because this is where I do my work. Remember that way. We call this as a working directory. This one, YCult61, we call that as a working directory or workspace. Workspace or working directory. Can you go to your working directory? Can you go to your workspace? That means they are asking you to go to the place where you cloned the repository. Working directory or workspace. Why we call it a working directory? That's where I do my work. Remember that. The local repository.git, why staging and things like that, right? Staging advantage. How Git generates the SHA value or commit ID. Try to use these terminologies. Understand about this? Any questions you have? Okay, we'll start the class now. I don't want to start the new topic, but I'm available. If you have any questions, I'm available for another 10-15 minutes. Any questions you have?
Is it mandatory to relay? I mean, depend on the command lines, or do we have any GUI to do these things, like how Windows supports GUI?
Git has a GUI also. Git has a GUI also, but as a DevOps, we should not be using GUI. GUI is for developers, for users, not for DevOps engineers. So developer can come and then say, okay, I don't want to learn Git commands, right? I will use GUI. That's easy for me. Tell them, okay, go ahead and then use it. But as a DevOps, if we use GUI, what will happen? We don't remember the commands. We don't know the commands, right? Since we don't know the commands, we cannot automate few things. And if you want to automate something, we need to run the CLI, right? Command line. So as a DevOps, it's not preferred to use GUI. Don't install it either. Not required.
Okay.
Because if you install once, just if you want to, feel it, install it, and then uninstall. Because if you don't uninstall, what will happen? If you have that in real time,
Correct.
since it's a simple one, we'll be tempted to use that always.
Yep.
Okay. Any other questions, guys? So these are all the simple commands. Actual DevOps engineer's role with respect to Git starts from here, branching. Whatever we discussed so far, these commands are used by everybody, developers, QA, you, me, and everybody. So branching from here, starts our own concepts. Only DevOps engineers only DevOps engineers do this, not everybody. Many things will be interesting.
Yeah. Do we have anything like code reviews also will be covered going forward, or?
No, Sai. There are some code review tools, but it's not part of the curriculum. That's okay because we don't, as is, developers work mostly with the code review and things like that. So, minor thing.
All right.
There is something called Gerrit. You can integrate Gerrit with Git. Gerrit is a code review tool.
Okay.
Git, Gerrit, remember that. Okay. Thank you, everybody. Good night.
Yeah. Thanks. Night.
Thank you.
Thank you.
Bye.